Now today, with 9.4, we're talking about special right triangles. Okay, not the same special right triangles we talked about with your Pythagorean triples. These are different. We have two special right triangles that we're going to use today. And what this is going to provide you the capability to do is you are now going to be able to find side lengths of a right triangle when you only know one side. Okay, in the past, to use Pythagorean theorem, you had to know two sides, correct? Okay, today they might only give you one side, but with this information, you can find the other two sides. Okay. Our two special right triangles are the 45-45, okay, meaning that if this is a right angle, the other two angles are both 45 degrees, and the 30-60. Those are the two special right triangles that we have. Now, also keep in mind, before we actually go into this, if these two base angles are congruent, what do you know about these two sides? If the two base angles are congruent, what do you know about the sides? Right, that was our base angles theorem from first semester. Okay, so this is what kind of a triangle? Isosceles. Okay, so those two sides are the same length, correct? Okay, just keep that in mind. Okay, but these are the two triangles we're going to be working with. Okay, you do have two theorems today. The first one, and we're going to split it up a little bit differently than your book does. We're going to do one at a time, and then we'll do the first one. We'll go through some examples. We'll do the second one. Go through some examples. The first one is a 45-45 right triangle. Does it actually have to mark that those are 45 degrees, or could it put congruent tick marks in there? Yeah, because if I have, and I'm going to erase this so you don't need to draw this. If I have this with congruent marks here, well, if this is 90, those have to add to, they have to add to 90, which means both of them would have to be 45. Okay, so it might not actually tell you the angle measures, but always look for other ways to figure it out. Okay, they might not always tell you. Okay, can everybody make sure they got their books open, please? 9.4. All right, now, this idea that we're working on today is going to be a little difficult at first. Okay, but most students, by the end of the day, you're going to feel like you got a pretty good hang of it. Okay, so just bear with me here. We'll get through some. It'll get easier as we go. It's actually going to start really easy. Then it's going to get harder. Now, when looking at this 45-45, okay, we know that those two legs are the same length, right? We just talked about that. It's an isosceles triangle. They have to be. Okay, the special thing about this right triangle, obviously if you knew one of these sides, you could do Pythagorean theorem because you'd know the other side, right? Hey, it's going to be a waste of your time, though, because what's going to happen is this side, if you just multiply it by the square root of 2, you're going to get your hypotenuse. So multiply one of your legs by the square root of 2, and you have your hypotenuse. So if the leg, one leg is 7, what's the hypotenuse? 7 square roots of 2. If that leg is 9, the hypotenuse is 9 square roots of 2. If that leg is 37, the hypotenuse is 37 square roots of 2. Is everybody getting that? I only hear a few of us answering. Okay, but we got that? Okay, so that's not the hard part. That's actually the really easy part. The hard part is when they tell you what this equals, and they want you to find this. Okay, obviously you would go through the equation, divide by the square root of 2, okay, but it's going to be a little more challenging than that. So what I want to make sure we have down is we need to write down our equation. I know that the hypotenuse is, well, what is the hypotenuse? It's the leg times what? The square root of 2. Okay, so it's a leg times the square root of 2. Your book does write this like this, and I believe I already talked about this with you guys. Why do I not want you to write it like that? It's hard to tell if the x is under the radical or not, right? Okay, so we want everything in front of your radical. Make your radical your very last thing, other than maybe like an inches label or whatever. Okay, so keep that radical in the back. Okay, so again, if this was 3, what's the hypotenuse? 3 square roots of 2. Okay, and then obviously this side over here would be 3 as well, correct? Okay, could we do that if they gave us a leg? Okay, just stick square root of 2 behind it and put it on the hypotenuse, right? Okay. The more challenging part comes when they do this to us. Okay, they give us our right triangle. They show us that it's 45, 45. Okay, they didn't write it, but we know that means that it is, right? And then they tell us that this side length right here is 12 inches. We want to know what x is. Okay. So what I would like you guys to do here is go ahead and use that equation. Hey, some of you are going to find a pattern eventually, and that's fine to use. Okay, but I want to take a look at that actual equation first. Okay, that equation tells us that the hypotenuse, which we know is 12, is what? The leg, which is x, times the square root of 2. Okay, I still personally to this day set that up every single time. Okay, I don't take any shortcuts. Okay, so I have this set up. Now the question is, how do I solve it? Obviously we're trying to solve for x, correct? Okay, how do I get x by itself here? Right, because I'm multiplying by the square root of 2 now, right? So to undo that, just like Carson said, I divide by the square root of 2. On both sides, right? So I actually have that x equals 12 divided by the square root of 2. Now we've touched on this. Is that an acceptable answer? No. Taylor, can you tell me why?
I don't know why.
Don't know why, but you know it's not.
Yeah.
Okay? Anybody tell me why that's not okay to have? It is not reduced because, and I know I've mentioned it in here, but we haven't talked about it a lot. I can't have a radical in the denominator. Okay, that's not okay. Okay, so we can't have this. Somehow we got to get rid of that. How did I get the radical out of the denominator? Not the reciprocal. I multiply both the top and the bottom by the denominator. That is called rationalizing the denominator. Okay, I'm rationalizing it. Right now, it's irrational because it comes out to a repeating decimal. Okay, I'm rationalizing it. I'm making it so it is not a repeating decimal anymore. Okay. Now, does anybody know why? I know in all your math, you've always, if you did it to the top, you did it to the bottom, right? Does anybody know why? Or is it just because that's what we've always just been told? It's a rule, right? My teacher told me that's what I have to do, so I have to do it every single time, right? Okay, the reason why, what is the square root of 2 over the square root of 2 equal to? Because anything over itself is 1, right? Okay, so the square root of 2, so if I'm multiplying by 1, am I actually changing it, or am I just writing it in a different way? I'm just writing it in a different way, okay? So that's the reason you multiply the top and the bottom by the same thing all the time, is because you're actually multiplying by 1. So you're not changing it, you're just writing it so it looks a little bit different. What is 12 times the square root of 2? 12 square roots of 2. What is the square root of 2 times the square root of 2? It's the square root of 4, which is 2. Now, I know we did a lot of review with this. Okay, can I reduce this?
Yes.
Yeah. 12 over 2 is 6 over 1. I don't need to write over 1. Can I reduce it this way? No. That's in a radical. That's not. So I actually have 6 square roots of 2. So, this length here, 6 square roots of 2. This length here, 6 square roots of 2. How are we doing?
Zach was helping me, and it all fell out.
Uh-oh.
What held it upside down?
That's okay. Did you get the ones that I needed?
Yeah.
Okay, that's okay. Don't worry about the rest of it. That'll be the last time I use that one anyways. We're getting new books next year. Yeah, just toss it in there. Thank you. Did you lock that cover back up? Okay, just put it back in there and lock it back up. Thanks, buddy. Yeah, that's not a problem. We won't. I won't need that next year, anyways. All right. So I know that was a lot. First one. Okay. The other classes have thought the first one was hard, but they thought the second one was easy. But we did the same thing. Okay. So let's just go through the second one, or another one. Okay. What do you want the hypotenuse to be? Anybody? Thanks, Braden. 18. Let's make it an odd number, okay? 17. Okay? So we got 17. I want to know what is the base. Okay? Well, from what we just talked about, I know that the hypotenuse, or 17, is equal to what? X square roots of 2. Everybody agree with that? That's straight out of our equation on our theorem sheet. Okay, so keep your theorem sheet handy. It's going to be useful here. So here at Taylor Hart, I do what? How do I undo multiplying by the square root of 2? Divide by the square root of 2. So now I have x equals 17 divided by the square root of 2, correct?
Yeah.
Okay, Royal. Next.
Multiply 17 over square root of 2 by square root of 2 over square root of 2.
Good, square root of 2 over square root of 2. On top, Amanda, I get what?
17
Good. On the bottom, it's going to be 2, because the square root of 2 times the square root of 2 is the square root of 4, right? And we know the square root of 4 is 2. Can I reduce this? No, because that's an odd number. Okay, so this side length is 17 square roots of 2 over 2. And this one over here would be 17 square roots of 2 over 2. Again, do you remember why we don't put that as a decimal? Decimals are rounded. Right? When I put a decimal, don't you round it? Hey, we don't want a rounded decimal. Hey, we don't want a rounded decimal, because if I were finding the area of this and I used a rounded decimal and you didn't, who's going to be more correct? The one who didn't. Hey, I might be off as much as, I don't know, 3 square units, 4 square units. It all depends on how much you round it and what numbers you're using to multiply, how big they are. Okay, so if you round something, your answer is going to be off the more things you use it for. Okay, so don't round. We don't want decimals. We do not want rounded answers. We want exact answers. Okay. Did it seem a little easier the second time? Kind of knew what was going on the second time, right? Okay. The next one we have, and make sure these are on your theorem sheets because they do tend to get confusing, is our 30-60 right triangle. He forgot to make my copies of theorem sheets. Alright, so I have 30-60 right triangle. So there's my 60 degrees. There's my 30 degrees. Now, the biggest thing with your 30-60s, everything revolves around the short leg. I'm circling this leg. How do I know this is the short leg? And don't tell me because it looks shorter. Okay, Jacob, your smallest side is always opposite side of your smallest angle. So just like Taylor was saying, it's opposite 30, so it's the shortest, right? Okay, everything is centered around that short leg. Everything. If you don't know the short leg, then you got to find the short leg. Okay? If you already know the short leg, then things are super easy from there. Okay? Your hypotenuse is 2 times the short leg. That's probably going to be pretty easy for you guys. If the short leg is 7, the hypotenuse is? Short leg is 9, hypotenuse is? Hypotenuse is 30, short leg is? 15. Hypotenuse is 40, short leg is? Okay, we can do that, right? We can multiply by 2, divide by 2. That's not hard. The long leg is where it's a little trickier. Okay, the long leg is the short leg times the square root of 3. Okay. So let's go through this scenario real quick. Let's say the hypotenuse is 16. What's this? 8, which makes this 8 square roots of 3. Hypotenuse is 100. Short leg is 50. You square rooted it. 100, 50, 50 square roots of 3. Okay? The hard part is when they tell you what this is, and you've got to go the other way. Okay, that's when it gets more difficult. Now, I do want to give you a little pointer. Some people get confused. How do I remember when to use the square root of 3 and when to use the square root of 2? Okay. First of all, it's on your theorem sheet. Second of all, 3 is divisible by 3, correct? 6 is divisible by 3. Would 45, out of 45, would 4 be divisible by 3? No. Okay, so up here on your 45, 45, 4 is divisible by 2, right? And 4 is divisible by 2. So look at the first number. If they're divisible, then you use that one. You with us, Lainey? Okay. Okay. Our rules or our equations for the 30-60 right triangle. First one's really easy. You'll probably never use it, but I'm going to put it up here for you anyways. Is that the hypotenuse is what? 2 times the short leg, right? Again, you'll probably never set that equation up because you can multiply something by 2 and divide it by 2 really easy. Okay? The one that you might need to set up is that the long leg is what? The short leg times the square root of 3. Again, everything revolves around that short leg, right? Okay. We are going to jump straight into one of the more difficult problems. Okay, the next one I'm going to give you, we're going to have that side. We're going to have to find the others. Okay. So, I have my 30-60 right triangle. Now, remember, might they rotate this triangle on you some? Okay, so it might not always be the same diagram that I'm drawing. Okay, so be aware of that. You still need to find your short side. Okay, in this case it's X. My long side is going to be Y. And we'll say that this is 18. Okay. Before today, you would have looked at this and said this wasn't possible because you can't use Pythagorean theorem with just one side, correct? Okay. After today, we know that we can set up an equation because I know that my long leg, which is 18, what do I know about it? It is the short leg, which is X, times the square root of 3. Okay. And from here I solve through just like I did on the 45-45. So what's my first step? Divide by the square root of 3. So I get X equals 18 over the square root of 3. Lainey, what's your next step when you're ready? Okay, so you're multiplying by the square root of 3 over the square root of 3. Paige, what do I get on top? 18 square roots of 3. And then on bottom page I get? What's square root of 3 times square root of 3? Square root of 9, which is 3. So just go ahead and multiply them, and then square root. And then Taylor-Stokes, what can I do here? I can reduce the 18 over 3 to 6 over 1, or just 6 square roots of 3. Okay. So I found what right there? The short leg, or X, right? So this is 6 square roots of 3. So, since we know that, Taylor Arnett, what is my hypotenuse? Hey, I always have an argument on that one right there. Is it 12 square roots of 3 or 12 square roots of 6? 12 square roots of 3. Because if I multiply 6 square roots of 3 times 2, I can't multiply that square root of 3 and the 2, can I? They're not like terms. Okay, that's got a square root, that doesn't. They don't go together. Okay, so Taylor was right when she told me 12 square roots of 3. Okay. All right. One more here. Actually, two more examples. One more basically like that one, though. Okay, so I have my right triangle. I know that it's a 30-60. Okay, but this time, they tell me that the hypotenuse is 19. We want to find both legs. Okay. Travis, what's the first one that we should find? The long leg or the short leg? The short leg, what is it? 19 over 2. 19 halves, right? Okay, we don't want the decimal, right? Okay, we want the fraction answer. Now, and I know you're going to come across this problem, or one like this. That's why I gave this to you. What do you have to do to get the long leg? I need to multiply 19 halves times the square root of 3. And the reason I'm going over this one is because I had a student say they weren't sure how to do this. How do I do this? Okay, that'd be the square root of 3 over 1, right? So on top I get 19 square roots of 3, and on the bottom I get 2. Is that an okay answer? Yeah. It's a great answer. Okay? Just so we know how to do that problem, because you will come across one that's like that. Okay. One more example. Are we ready? Last one. Okay, the last one that we're going to do, I think it's example 5 in your book, maybe. Okay, basically, it's a yield sign, like a traffic sign, and they basically forgot about because the yield sign has rounded corners, they forgot about those and just pretended that they were pointed. So there was an actual triangle. And then they told us that they split it. This was 18 inches. This was 36 inches. They want us to find the area of this triangle. Now, we've already done problems like this because I can use Pythagorean theorem here, can't I? Yeah, but it's going to take you longer. Hey, if you know your 30-60 rule, it's going to be a lot faster. How do I know this is a 30-60 right triangle? Well, if all my corners are the same out of the big triangle, that means each of them is 60 degrees. Okay, well, this one I split in half, so that must be 30 degrees. So I have a 30-60, right? And my short leg is how long? 18, because it's opposite 30. Okay, so Taylor Hart, what's my long leg then? 18 is half of. Am I saying this wrong? Yeah, no. The hypotenuse is twice the leg, the short leg. The long leg is the short leg times the square root of 3, like you just said. You stumped me for a second when you said it's half of it. These are half, right? The hypotenuse and the short leg. Okay. So now I have. Now, did we just do that a lot faster than if we put the Pythagorean theorem in, squared everything, subtracted it, square rooted, and then you have to reduce a radical? That's a lot faster to do it this way, right? Okay, so if you can know these, it's a lot faster. Why did I have to find my height? Right, area of a triangle is 1/2 base times height, right? Okay, so let's go ahead and set that up. My area is 1/2. What's my base? You're the first class that didn't say 18. Why is it 36? 18 is only half of it, right? We want the area of the whole triangle. So I have 36 times the height, which is 18 square roots of 3. Well, half of 36, 18 times 18 square roots of 3. 18 times 18 is? Pretty sure. Check it. Pretty sure that's right, though. 324? You forgot to carry a 1. 324 square roots of 3. Okay, don't forget about that square root of 3 up there. My label Inches squared. I will also want you to be very careful on that. On 9.2, a lot of people lost points on their homework because they either didn't square this. Is that the same answer? No, that's a long ways off. Or they didn't even put a label. And then I don't even know how far you're off. I don't know if that's in yards, meters, miles, and it's supposed to be in inches. You could be a long ways off if you don't put a label, right? There's a big difference. Make sure you have a label and make sure it's the correct label. If you're talking area, it would be units squared. If you're talking perimeter, it would just be units. Okay, so make sure if you need a label, make sure it's there. Okay. Questions on that? We feel a little more comfortable than we did the first time we did the 45-45. Okay, use your equations, set them up. The plan for this week, since we don't have school Thursday, Friday, and actually this would be the plan no matter what. Okay, today and tomorrow we're doing 9.4. Okay, so we are doing an add-on tomorrow. Okay, I want this assignment mostly or all the way done for tomorrow. The next day we will do 9.5. Okay. And then the next class period, we'll do another portion of 9.5. So we'll add on again. Okay, so we have 2 assignments in 4 class periods, basically. Today, add on tomorrow. Next class, we get another assignment, and then we add on again.
So we're going to have that second add-on on Monday?
Correct. Yes.
I know, including me, a lot of business law people are going to be on Wednesday.
Okay. The video will be posted. Okay? The video will be online. And then lucky for you, we're adding on the next class period anyways. But you'll have to watch the video to get the information. Yeah, Taylor? Okay, give me 1 second, okay? Let's see. Quickly. Alright, here's what I need you guys to do and have done for tomorrow. Please.